Okay, good morning. All right, this is a bit where I secretly check my mics are still working by saying inane things at you. That seems to be working. I can hear myself. Raise your hand if you can hear me. Raise your hand if you hate speakers who make you raise your hand. You're going to love me. Right. Good morning. It is an absolute privilege and a surprise to be a security person doing a keynote at a developer conference. Like, can I get a woo for like the brave new terrifying future we're all in? So, hooray, yay. This talk is a really great opportunity for me. It's, this type of talk isn't, I'm not here to show you lines and code and go, hey, here's some syntax and you should love it. I'm here to share a little bit of an adventure I've been on, because I've been lots of things: a software developer, a security person, all sorts of things. And even in my 20 plus years of doing this, so much has changed. Raise your hand if you've been doing this more than 5 years, more than 10, more than 20. Arm doesn't work anymore, it's sore, don't make me put it down. All right, so this is me. I am a fairly average 38-year-old. I do code stuff. I write terrible code, a lot. I write some average code when there's good peer review on it. But I am unusual in that I'm a bit of a security optimist, which is about the most dissonance you're going to get in this conference. I am genuinely excited about the future of technology. Raise your hand if you're excited about the technology we are building today. Not what you're paid to do, but the other stuff, the stuff over there. Great, awesome. We're not quite building the fifth element, and nobody aspires to be that. But we are building some pretty cool stuff. Now, ignore the Tesla nonsense that gets launched. But even just look at robots. I love robots. My thesis was in artificial intelligence and robotics before that was actually a career path. And so I look at what Boston Dynamics are doing, and I'm like, this is pretty cool. Also terrifying, because Spot the dog when I was a kid was small and yellow and kept getting lost somewhere and not coming home for dinner. But this Spot I don't think is going to get lost. And in fact, it's going to probably make sure nobody is late for dinner. I love robot doctors. I love the fact that we are taking people to space, even if I'm kind of convinced it's a bit of a shadow enterprise in mining, but we'll just leave that to the side. I love the fact that the sci-fi future that I read about and I watched when I was growing up is being built. And not just is it being built, but it could be being built by us, by people just like us. It's not some kind of that has to sit in a funny place that invents it. It's literally the software engineers in this room and beyond. And that's cool. But it's also a little bit scary, because with that great power comes great responsibility, if you believe the cliches. And it really does, because with every amazing robot army dog thing we have to then make sure this thing doesn't go wrong, and that we don't use it to share government secrets or something. I don't know. What would you possibly do with a robot dog if you hacked it? Who knows? So in this talk, I'm going to do 3 things. I decided that if I was going to understand how we secure this amazing future, I was going to take a look at the code I'd written in the past and take a look at how that had changed and how that had impacted the security of what it is now. So I've picked 3 things that I have been involved in building and taking a look at those. Then I'm going to share with us some of the changes that we're going to have to face as engineers. This is not about SQL injection. The future of security looks very different to what you've been taught so far. And then at the end, and spoilers, foreshadowing, there's going to be a QR code, and it's not a Rickroll. Because I'm trying to do something. I want to give all of you a gift of extra work to do, which I know is your favorite sort of conference swag. So watch for that at the end. But let's have a little bit of an adventure through space and time while I share what I have worked on. Now, I'm not here to show off that these were cool things. I thought they were cool. You're going to have your own adventures. You'll have your own examples of systems you've worked on that would be completely different now. But it helps tell the story. So this is me. This is me in a timeline. I started out as a software developer, age 16, entirely by accident. I got made homeless a little bit suddenly. Somebody got very sick. And in my hometown, which is famous for two things, teenage pregnancy and car theft, there was 2 job options available. I could go and work for somewhere like a factory or, McDonald's, somewhere in kind of, it would pay the bills, but it wasn't particularly glamorous. Or EDS happened to have a big office in my hometown. And EDS doesn't really exist anymore. It was acquired by HP. But they did software development for the Inland Revenue in the UK. And so, at the age of 16, I took on the brave new future as a COBOL developer. This was in the year 2000, so you can see how far from the future I really actually was. Now, from there, I've been on an amazing adventure, and I've been incredibly lucky, and I've also been really silly at times and just taken chances that I didn't know what was going to happen. But that's fine too. I've done AI and robotics. Before that was a job option at university, having spent a lot of money coming out with a degree nobody understood. I worked at CERN for the LHC, and we're going to talk a bit about that. I've done counter-terrorism and counter-pedophilia, and I have done penetration testing and red teaming and hacking. And now I live in a strange world where I help very fast-paced software development teams all around the world figure out how to do security for whatever they're building. So if you think about it this way, I've become that weird little pencil note on a recipe. So I don't know if any of you have recipe books at home. It's still a thing, I'm told. But you look at that recipe that's been passed down from your nan or whoever, and somewhere there's a pencil note that scribbled out something and said, do not do this, it will suck. And nobody knows where that pencil note came from. Nobody knows who wrote it or when. But you know if you follow that tiny instruction, then the cake is going to be better at the end. And that's what security is to me. I'm trying to make a lot of cakes taste a little bit better and be forgotten. So let's get into it. The first thing about securing the future has to be Internet of Things. And I started off in Internet of Things at CERN. Internet of Things back in 2005 was not what we're used to now. How many, raise your hand if you have an Internet of Things device on you today. It's probably a smartwatch, to be honest. Any of you got the smart socks? I'm curious to know who buys those. No? Okay, all right, I'm still going to keep trying. IoT back then, and back for me, was about physics. My job was to monitor background radiation at the LHC, so the Large Hadron Collider, which is a giant particle accelerator underneath Switzerland and underneath the French border, and decide that a radiation threshold had been met and decide to do some stuff. Okay, good. Just to be clear, for anyone who's not a physics nerd, I was not a physics nerd. I applied for a job because it was in Switzerland. But hey-ho, doing stuff means that you've got lots and lots of particles whizzing around really, 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 really fast. And if you happen to, say, aim them at a human, bad things will happen. So instead of letting bad things happen, if the radiation escapes from where it's supposed to be, you send it to the place labeled dump, which is essentially a giant concrete chamber underneath the ground that has been built specifically to withstand radiation. So I was 23, no pressure. There was me on this project, me and one senior hardware engineer from the Netherlands. That's what Internet of Things looked like back then. It was custom-built electronic devices and firmware that at the time were being mostly coded in things like C++, in terms of the application layer. There was talk of real-time Java. There was very furious talk of real-time Java, and there had been since 1996. It didn't happen. But this is our lives. We had a small porter cabin on a site in Geneva. We built devices, we wrote software, and then we threshold tested it with absolutely no fancy tools at all, and then we buried it under the ground and hoped the radiation thing worked out. Fantastic. Now, thankfully, Internet of Things now isn't all about large, deadly doses of radiation. That's good. Fantastic. How many of you write software that's to do with radiation? Anyone? It's super fun. You could go do that if you wanted. The solution now, though, is very different, right? All right, perhaps not for particle accelerators, but IoT is everywhere. It's everywhere to the point that this morning, literally reading my news this morning, President Biden in the US has declared that the Cybersecurity Center is going to create a voluntary standard for the security of IoT things. Now, the key word being voluntary here, so we'll see how that goes. But it's a sign of the times. There is so much IoT now. There are so many different devices and ways it's impacting our lives that a nation state that is considered one of the most powerful on Earth has decided, yeah, we might want to think about some rules or something. How many of you do any IoT development for fun or profit? I know at least one of you does. I spoke to him over the last 2 days. You should totally talk to the dude who does irrigation systems for a living. It's fascinating stuff. Now, if you wanted to do it, you can go to AWS. You can download a whole range of off-the-shelf SDKs and get going. You can buy commodity hardware from general stores. You can go to a store and buy an Arduino kit if you want and just get going. It doesn't take a lot of expense. It doesn't take a lot of time. And this is a great thing. And also, as a security person, it's absolutely terrifying. Because this means that every single person who wants to can build a little device that can do something, measure something, change something in our world, and then leave them there. And they're everywhere. And as a security person who's also a developer, I find myself torn in two at the concept. I'm like, yes, this is exciting, but also why? So every element from our gardens onwards is connected to Bluetooth. Now, every time you do an IoT security thing, you should always go and look at AliExpress. So just for, if you want fun and profit, I wanted to see if I was writing radiation monitoring software today, would I even need to bother? Do they already create commodity hardware for managing radiation and then connecting it to your phone? Well, of course they do. So it only has a 1-star review, so I'm not commercially involved in this in any way. But everything you can imagine that would be an IoT device right now is not just being made by engineers who are sat in this room who care about professional development, who are trying to be great, high-quality engineers. It is being built, in often cases, for the lowest possible cost in locations all around the world and sold online to people who just want to solve a problem. And that, to me, is exciting but terrifying because where's the responsibility in this? How do we know that this works? How do we know where the data's going? The OWASP Top 10 isn't built to protect you from an IoT Geiger counter. It's not in the threat model. And IoT applications are everywhere, right? From health, so our smartwatches, our scales, our medical systems in our hospitals. So when we see ransomware attacks, we see where this goes wrong and people get hurt. It's also in our retail with the increasing rise in being able to shop without, talking to a human being, because who wants to do that anymore? We have it everywhere, and we will see more of it. And we will see more of it to an extent that we will forget that they're computers. And from a security point of view, that's really hard. When you forget something is software. When you forget that it is the lines of logic that you're used to creating, then security becomes very difficult for you to focus on. Because, well, you're just watering your garden. You're just telling the time and measuring your heart rate. You're not thinking about the thousands and thousands of lines of code and the connectivity that is around you all the time to make that work. The next thing I decided to try and do, because being ahead of my time and not paid for it was super fun, was I got really into natural language processing, and this was my happy place in 2005. In 2005, I decided I was going to write an application that would help me learn French. This was well before Duolingo was a thing. The idea was I wanted to talk to somebody in French, and I wanted them to talk back to me in French, and I wanted them to tell me that my French was not terrible, or at least give me pointers in the right direction. What I'm saying is I really wanted to have a friend, and I was really not good at that. So instead, I wrote code. Has anyone done that before? It's like, I don't have a friend right now, I'll just build something. It's all right, I don't judge, you're amongst friends. So that's what I did. I built software. It was a thing. It was 30,000 lines of Java. Now, if you're going to write natural language processing tools right now, you're not going to choose Java as your language. But in 2005, that was really the strongest language we had for this. Now, Python and Perl were still a thing, but we'll come back to Perl later and why that's never a good idea. But there were no existing libraries and frameworks. Even in academia, these were largely theoretical. The tests and things that were being done with NLP were the foundations of what would later pass Turing tests, but it was experimental. What we had to do was we read really fun books like this one. It's very expensive, don't go buy it, find it in a library. But it was essentially statistical modeling of language. and then turning it into the biggest if statement you have ever considered in your entire life. If you looked at the 30,000 lines of code, I'd say 70% of it was nested ifs. And that was the reality of AI at that point. But there was a fancy name for it. It wasn't called giant if statement AI. But that's what it was. And it worked. It took a conversation, and it gave back some comments and feedback, and it gave me a friend to learn French from. I didn't get very far with it because, after writing 30,000 lines of nested if statements, I decided going out and getting some sunshine was a good idea. But there was no cloud computing. It was all running locally. The interfaces, as you can imagine, in 2005 were as glorious as they were in the ASP space at that time, let alone the Java Swing monstrosities we were building. So what's changed? How many of you are writing AI or machine learning systems now? Any of you been playing with it? You should totally have a play. If you haven't, it's an amazing space now. Now, I decided a few weeks ago, I have an innovation day at my company, and I was like, right, screw this. I'm going to see if I can rebuild what I built a long time ago, revisit my youth, do the things that you do when you were young. And I was delighted. Not only were there one or two frameworks, there were dozens of frameworks available. I could literally, off the shelf, pull a framework in Python, and off I went. They were pre-compiled corpuses, not just in English, but in multiple languages, not just big corpuses, so corpuses being giant collections of words that have been annotated in a way so that you can process the meaning of language. But there were small versions suitable for mobile. Great, wonderful. I didn't need to do anything. In fact, I didn't. My code, which was previously 30,000 lines of Java, boiled down to 2 slides worth of code. Now, part of me was delighted. Hooray, exciting future. I can now build the friend that I've always wanted. But then part of me was like, well, hang on a second. I know how much complexity was under the hood when I built this the first time. And if any of you have ever built networking connection code, so you've had to set up the ports and the connections, you will know this. When you first wrote it and you had to handle the connections and you had to make sure everything was synchronous and everything worked. And now we don't. Now we have one line in our framework that sets it up for us. Now, does this mean we don't have to do security anymore because the framework is there and it's easy? No, it just changes the way we have to think about security because we're not controlling any of this anymore. We've got a big corpus of data that we can use that somebody else built. I'm sure that's fine, right? You just use software from other people off the internet all the time. That's perfectly fine. That was the other part of it. This little bit here, for anyone who cares, I don't do live demos because nobody actually really enjoys them that much. This looks for certain parts of speech. I was particularly interested in pulling out keyword phrases from some large text. So I wanted to know if I was going to create a glossary of text, could I do that? Turns out I could. I could just decide which parts of phrases I wanted and the relations they should have to each other, and I could just dump them all out. Fantastic. Now, in a way, the problem was solved, and I felt a bit sad because security and coding had become too easy. But this was it. What had been 30,000 lines of painful code is now this. In fact, it gets worse, because then I was like, well, I'm not really excited by this Python now because, well, somebody did the hard bit. So I went online and found out that not only is there a Gartner quadrant for this, but you can now have a low-code and no-code interface to build your own artificial intelligent chatbot. Fantastic, we've all been replaced. So the future is bright, the future is no-code. Any of you embracing no-code in your world right now? Or you've got some of it going on? Yeah, does anyone feel a bit weird about going down the no-code route? It's like cheating? Well, when we get to this level of abstraction from what we're trying to do, as a security person, I really start getting a bit nervous. Because it's wonderful that I can create my best friend with no code. But what's actually going on under there? How do you understand the risks in a system that you cannot see the pathways through? That you can't understand the decisions that are being made, where you can't understand the data that is being used to feed it, to make those decisions. Now, that got me thinking, and I'm going to come back to what it got me thinking about. I decided after I was playing with my natural language things, and that was not making me happy anymore, that I would revisit the last of these projects. Now, back in 2007, I was employed by GCHQ, and one of the things I was involved in was counterterrorism and reducing online harm to children. Now, I'm not here to talk about intelligence services. Literally, they put me in prison if I do that. But they don't mind if I talk about nerdy things, so that's okay. My job was to map the relationships between individuals in online social communities, identify aliases and fake accounts, and identify those with power and influence in networks. Now, if any of you have actually been on the internet in the last 2 weeks, you might notice that even in 2007, we had exactly the same problems as we have now with fake accounts, disinformation, power brokers and aliases, sock puppets. The whole thing has been going a very long time. So if anyone turns around and tells you this is a new problem on the internet, they're young. There's a few of us who've been around a while that know this is not a new problem. This is a human problem. And for as long as there's been humans, humans have pretended to be other humans to essentially cause trouble. Now, how many of you are old enough to know or have used a forum like this? Oh, hi, old people, my people. Yeah, this is vBulletin now. vBulletin was the thing. It was the forum software, the most popular forum software on the internet between 2000 and 2007 when it was first acquired. It eventually died out and stopped having any active development in 2012. But at this point in time, whether you were a gamer or doing nasty things on the internet, you probably set up your communities using software that looked a lot like this. And, you know, it did the job. It was PHP. It was not the most glamorous PHP. In fact, there's a really well-publicized incident that happened with vBulletin. That's one of the reasons it became less popular, where you could there was a vulnerability to let you get the password to the admin account of the vBulletin server with no technical ability. So that led to some problems, you might imagine, in controlling the communities. But my job was to take forums like this and Jabber and the tail end of ICQ and all of those messaging systems we wish had died and turn them into the connections between humans. Now, how did that work back then? It involved a lot of Perl and regex. And I have still got my little O'Reilly regex tiny little handbook, which is so well thumbed that the pages are now decrepit and you probably wouldn't want to touch it from a hygiene perspective. But my job was to take really mangled data that wasn't designed to be mapped or graphed or to be deambiguated and turn it into nice things. Those nice things being used to identify the people who were causing harm to others. So from my point of view, it was a very important mission. And it was horrible work. Now, how many of you are sat there going, yeah, but would you really write Perl? Because like D3 is a thing. And any of you like sat there going, I know better? I just want to remind you of a timeline. vBulletin launched in 2000. Facebook, which is where a lot of communities then ended up, and then Tor and all of those weird places, came much later. Facebook first launched in 2004, but it was closed. It was only for university students at that point. The Facebook we know and love didn't really start getting popular until, say, 2010, 2011. So we had this period between 2000 and 2010 where these forums were still very, very much the popular place for a community to hang out. The tooling you would have chosen to write this in literally wasn't launched yet. D3, the nice thing that you'd use to graph out some really simple things in JavaScript, we've all done it at some point or other, wasn't launched until 2011. So whenever we had to do a visualization, whenever we had to map out connections between data, we had to build it ourselves. And I'm not that survivor person who says, yeah, you had to do it yourself and that made me cool. It didn't. It made me really tired. But from a security point of view, I knew what I'd written. At this point in time, I started getting active in OWASP, and I was part of what was called the ESAPI project for PHP. Now, that was a library that existed because PHP at the time didn't have any security built in. And before you all go, yeah, but lol, PHP, looking at you, all the other languages that got there just as late. Every language had one of these ESAPI frameworks, and it was a bolt-on designed to give you security controls where there were none in your framework. At that point in time, there was nothing that we could do that was simple, so we knew explicitly where we had to put the security, because we had to do it line by line. If it didn't exist, we had to write the library to do it for us. Now, I love this. This is not mine. And it doesn't count. It goes only up to 2015-ish. But I don't know where you are on this. But if you map out your journey in the languages you've seen and used, you start to really realize how we take for granted in the libraries and frameworks that we're using now, and how many of them are actually really recent things. Now, that's really relevant for security, because some of the stuff we're building now, while it is being built at this future end, where we've got all these cool toys to play with, we're building technology that wasn't imagined when these libraries and frameworks were created. So a lot of what we're doing in IoT with these commoditized products, what we're doing in natural language processing, while we're at this end of the timeline, it doesn't mean we're at the end of the maturity. We don't have the 15 years that some of our languages have had to mature their frameworks and their standards. So what's the solution now to mapping out data? Well, I want to show you a library, actually, that you can go and do. If any of you do any Python, this is quite good fun. There are many frameworks that could help you analyze any sort of connected data, and they come mostly from the security community. So if you don't hang out in that place, I don't blame you, this could be your time to go and have a look into the threat intelligence space. But I have to start with a story. So there's a really wonderful security researcher called Thomas Rocha. He is part of the Microsoft Threat Intelligence Group, and he tells this story very well. Do check out his talks. But he does research, and his tools have been developed because of things like the Conti breach. Any of you heard of the Conti ransomware? Yeah? If you haven't, it's the biggest, most effective ransomware of the last 2 years. It was decimating organizations globally. It was a dual-fronted ransomware attack whereby you were having to pay to get your data unlocked, but then later on they were also making you pay for not releasing your data because, they had it too, so, they could then send it to whoever they liked. It's believed to have been Russian state-owned. There's a lot of evidence behind that, and it affects all versions of Windows and was highly engineered. Now, you think your DevOps is good? You wait till you see how ransomware gangs operate. If you want to learn who's at the cutting edge of fast-paced software development that's multi-platform, don't look in dev. Look in the aggressive security community, because they've got their game on. The United States government thought this was so problematic that they offered a $10 million reward for any information relating to this. Now, that's unprecedented for a government to offer a reward for that kind of problem. Now, what happened, though, in February this year is the Ukraine conflict started, which, I'm not here to comment on that. It's a terrible, terrible event that continues to be a really horrible situation today. Now, the Conti group, being Russian-backed, put out a proclamation. They said that they were supporters of the Russian attempts on Ukraine and that they would retaliate against anyone who was seen to be supporting Ukraine. Now, much to Conti's disgust, an anonymous member of the Conti group did not share this viewpoint and decided to leak all of their messages. And this message chats, these logs go from the beginning of 2020 to February 2022, every message sent from Conti as an organization to each other. Now, this is gold if you're in threat intelligence. If your job is to understand a community, identify the power makers, identify where they're doing things and how they're doing things, this is the data set you want to be playing with. It was 60,000 fragmented chat messages across platforms like Jabber and Rocket Chat. Like I said about the vBulletin thing, never underestimate what technologies are still being used out there online to get the job done in certain circles. Now, if I'd have done this by hand back in the day, this would have been very, very painful. Fragmented data is like that. So let me show you what Microsoft did. Microsoft did a good thing. I'm not a Microsoft employee, never have been, but I've got to respect them for this. In 2019, before this happened, they open sourced something called Mystic, which is a Python framework for threat intelligence and security. And what it does is it turns large sets of data that you might see in an attack, like URLs and people and payloads and all these kind of things. It has this idea that you'd want to collect all the information about it and map it all together to tell the story so that you can investigate. So it's been released, open source and free. You can go and get it today. And whereas back in the day we would have had to really very manually map this data, it's very simple. These are 4 examples from their docs of how to create a social network from data. You just simply say, hey, I have an object of X type, You add that object as an incident or an alert or a person or a URL, and then you say, entity graph. It's like some magic word. It's cool. Now, for somebody who wants to just get the job done, this is amazing. And it gives you this graph. Now, it doesn't just give you that graph, though. It gives you this graph. This is a map of the Conti network. This is all the people inside Conti, the organization. And what they were able to do was not just track down, oh, there were 20 people and they were kind of nice. They could identify who was actually who, to the point where, oh, that person over there is actually also that person over there. Haha, fun. Now, what can you do with that data? You can stop bad things from happening. Now, not all of you work in spaces where you try and stop bad things happening for a living. That's cool. That's a good life choice. It's hard work. But in your world, being able to identify data that is actually the same as each other in some way and deconflict that is really cool. The future of technology is looking a lot like components we can pull together to do amazing things without the hard work. And that's not a bad thing, but it changes the way we do security. It changes it because the guidelines we have today, the way that we do software, the OWASP Top 10, and I love OWASP, please don't take this the wrong way. Those guidelines were not built with the future in mind. I want to show you something. This is the OWASP Top 10 in 2003 and in 2021. So this is the oldest and newest version of the OWASP Top 10. Now, who wants to play Spot the Difference? Yeah, if you have a look there, even if they're called slightly different things, at least 60% of the OWASP Top 10 has not changed in 15 years. But when I look at what you've done in the last 15 years and what I've done in software in the last 15 years, I've gone from writing 30,000 lines of Java to writing 6 lines in a framework I found on the internet. Are these guidelines really going to help us in a world where we aren't controlling all of the processing of information anymore, that we're trusting other components to do it for us? This makes it really hard. Our guidelines now protect us from what has previously been, not what is coming next. They're like your employee handbook at work, or the reason we have beware there's nuts on a peanut packet. It's the scar tissue of a previous mistake. And it's not a bad thing, but we need to anticipate the mistakes we, myself included, are going to make in the future. And we need some guidance right now about how we're going to adapt to this. Because the OWASP Top 10 is not going to help us if we are using these commodity components, if we are using things that are built from other people's code. Now, you could argue that, well, the other people are responsible for the security, right? They provided the library, they should do it. But who's going to hold them to that? Is it going to be the voluntary standard from the US government? Is it going to be you? Are you going to be like due diligence person with your spreadsheet? Hey, open source project, I need you to have met this checklist. It's not going to work. So we have to do something else. We have to have security guidance that copes with problems we aren't seeing yet. So increased architectural complexity. Distributed systems are no longer theoretical, they are mainstream. If you're not split into microservices, you're probably over multiple different clouds in some way or another, and you're using third-party components in the form of libraries and frameworks, as well as third-party SaaS solutions, many of which are currently being advertised to you in the lovely Expo area today. All of us are connected. We have a larger development community. There are 30 million software developers in the world today, 30 million, and it grows at a rate of 6%. That's 1.2 million per year. Now, if we could all fit all of us in the dev community in one room and say, hey, team, can we all agree we need to do security? Let's do it now. Can we all agree we need to do security? Raise your hand, please. If you don't raise your hand, you're staying until you do. Good. Easy, great. I can see all of you. I know where you work. It's on your T-shirts. We'll sort it all out. But 30 million people, how are you even going to do that? You cannot imagine how much software that is. It's incomprehensible. Our software no longer has linear code pathways. So when we've done our testing and our intelligence before, we would look at it and go, OK, so if I do this here, the output will be this over here. But with many of our emergent behavior systems, that's not how they work. There is a dynamic, ever-changing model of what the outcome would be based on the data that's going in. that makes it really hard for us to do some form of static analysis or threat analysis on that system. There's increased regulation. Now, we're in Australia. I'm not here to bag on Optus. Hug ups to the Optus team. You've had a really bad 2 weeks. But regulation is coming as a result. It will absolutely come. And it will change things that will impact all of us, whether you deal with telco data or whether you deal with Optus or another telco. It will ripple through our whole community. We have new categories of problems to solve, predefined corpuses of data. Now, if any of you remember the whole Microsoft made a chatbot and it became a Nazi fiasco, that's going to happen again. Because whenever you put data in, if that data is bad, bad things will come out the other end. And who looks at the data? Well, nobody, because these are huge sets of data. So how do we do that? How do we look at pre-trained models and decide they're okay and safe? How do we look at large, complex data sets without exposing individuals to harm because we've got too much data and we don't know how to protect it? How do we deal with mass-produced commodity technologies and libraries and frameworks without slowing down so much that we get in the way of it being mass and commodity and fun? My world is hard right now. Your world is hard right now. I want you to build a crazy sci-fi future, and I also want you to take very good care while you're doing it. Great. What could possibly go wrong? So if we've got these 30 million developers, then what can we do? Let's start talking about that. Firstly, we need to omit a few harsh home truths. Only 2% of organizations right now, according to multiple global surveys, are actually doing any application security. Raise your hand if your organization is not Veracode and you do a lot of AppSec. I know there's at least one Veracode person in the room, so. Are you doing any AppSec, folks? Oh, good on you, you few. I love you. Keep doing it. Keep fight the fight. The rest of you, what? The rest of us, a lot of us fit into this fragmented exploration. We're giving it a shot. We know there's a thing we probably need to do, but where do you even begin? You're going to say, I've got to protect my code against a threat that I cannot see, taste, smell, or hear, that may or may not exist in Russia, don't know, that there's a law that may or may not understand that threat, and by the way, I've got 37 hours in my week and my sprint is full already. Great, it's going to go super well. Many of us are in this emerging space. We're not doing anything yet. And today, hopefully, if I can do anything in this, I'm going to get that to change just a little bit. So what are we going to do to secure the future? What is our option? Well, firstly, we need to understand that you and the code you write do not do so in isolation. The future of security is not about one system and one piece of code. It's about the community that we live in and that we build into. Each and every one of you builds something different, whether it's things you do for fun and for hobbies or whether it's things you do professionally. Whether you actively code right now anymore or you've moved on and you're managing other people who write code. Each one of these items in our ecosystem has risk with it. The libraries and components we build from, the applications we build out of those, the architectures we turn those into, the companies and organizations we build those from, and then the relationships between those organizations. So I run a very small company. We're 21 people. We don't have a lot of software, just a few projects, because we don't need to build much more than that. But we have over 200 dependencies. We have at least 6 cloud suppliers that are directly connected in to our stack, things like authentication providers. We have another 102 vendors that we share data with for various reasons, from doing our accounts each month to ordering cupcakes when it's someone's birthday. Now, if you think about attack being around the motivation and what you want to do as a bad person, it's not about, hey, I love SQL injection, let's go do that. It's about, hey, I love money, how do I get that? Or, hey, I have a political problem with people in checked shirts, so hey, gentleman in a checked shirt over there, we're going to have a bit of trouble. That's what we're trying to protect against. We're trying to protect against motivation. And it's not that they're going to go and say, hey, I really like that you've got a sophisticated .NET application, I'm going to totally come after that. They're going to take the easiest pathway to get to what they want. Now, if that pathway is going after your application, so be it. But if that application is actually really secure, they might go after another weak link in that chain. And in my chain, that's 200 libraries, multiple SaaS providers, 102 suppliers, it's 21 people on my team, you start to see how many things you need to protect and understand the risk of. We call this transitive risk, the risk you inherit from others, and nobody's immune from it. In fact, COVID taught us about transitive risk in a way that we've never really looked at as humans alive today. Transitive risk of being made sick by somebody who happens to be in the same place as you is the same risk that we have of inheriting security vulnerability from a technology or a component or a system or a company that we work with. So what we have to do is understand this risk and how it impacts on us, if that's how we are going to secure the future. So what it's going to need. This picture is from Vanka. It's a visualization of some of the packages in the Node ecosystem. This is not a Rickroll. You can go there and you can go play around with it. But for me, it's a really physical, visceral reminder of how connected we are. That one package that I mapped there links to 358 other packages. And that in turn will link to an exponential number of projects and packages, whether you're a Node shop or not. I bet somehow you're connected to that package, just there. And that means we have to figure out, as a community, how we protect all of us. Because what we're seeing now is more supply chain attacks. A supply chain attack is a very fancy way of saying, hey, so I'm quite efficient as an attacker. I'm not really interested in attacking each of you individually. To be honest, I don't care that much. But if I can get all of you, cool. So it's much easier to attack a component that you all use than it is to go after each of you individually. Now, hug ups again to the Heroku folks. I'm certainly not here to bag on anyone's security, but I'm using them because this happened recently. This was April this year. If you want to see a supply chain attack in action, look at what happened there. Heroku had a compromise. Now, Heroku is hosting 13 million applications for 9,500 paying customers and a lot of free users. How many of you use Heroku for even a pet project of yours? Yeah? It's easy, it's free. You go roll stuff up, it's fantastic. But somebody compromised it and was able to get the keys to environments. Now, you could be like, that's fine, nobody uses it for anything sensitive, but even just looking on their website, these are 3 of their headline customers and what they use Heroku for. So, GoToMeeting for video chats. Thankfully, nobody ever works from home and we never use video chat. So, minor risk, low accepted. Domain names, DNS is never the problem in any issue. DNS has absolutely no critical role to play in any part of our security infrastructure, so we're fine. Job 2, low priority, low risk, accepted. ThinkMD, online patient management system for doctors. Fantastic. None of you ever get sick, right? No? Sickness is very rare in this day and age. COVID was all a myth. No, it really wasn't. This is 3 out of 13 million applications. So why would you attack ThinkMD when you can go after Heroku? How many of you use Azure? How many of you use AWS? Don't be ashamed. I know there's .NET folk in the room. Anyone using Google Cloud? Oh. Sorry, that was a cheap shot and it was not warranted. Why would you attack individuals when you can go after shared components? Maybe you wouldn't go after Azure, maybe you wouldn't go after Google Cloud Platform because that's like attacking the entire country. But maybe you'd go after a library that everyone uses, or a smaller SaaS provider that's really just growing and starting out and getting that traction. And that's terrifying. We don't want those younger companies, those shared components to be vulnerable. We've got to figure out how to protect us. To protect ourselves, we have to protect all of us. And that's really, really hard. So what do I want you to do? I want you to go back to your organizations or whatever you do in the software world. And I want you to take a real look, not at the code you write, but the code you use to write the future. All of those libraries, those frameworks, those SaaS products, whether it's a hobby project or a professional one. And I want you to understand the scope of the ecosystem that touches your world. And think about how you might be able to think about some of the challenges I've discussed today, things like pre-made libraries and corpuses, non-linear pathways through code, and how you can start to rationalize and understand that for yourself. Because when one of us is breached, if that one of us is in the right place, all of us are at risk. And that's a problem. The future of security isn't about SQL injection and that one line of code you're super proud of. The future of security, and the future of software security in particular, is trying to figure out a way to get 30 million people to act as one to stand up against some of the biggest automated, well-DevOpsed pipelines of attack you can possibly imagine. You need to understand your architectural complexity, secure your third-party integrations, turn on 2FA. God, seriously, it's like 2022. Include the entire community. We need to maintain availability at all times. It's tricky. And I want you to pick one of these and just run with it. Because if you just take one of them, you're further ahead than most of us are. Do you remember? Only 2% of us are actually doing this, and none of us in this room. The future of secure development doesn't belong to people like me. I'm on a mission right now, a really very loud and annoying mission. My mission is to make myself redundant, because the future of software security doesn't belong to a nerd who became a penetration tester and happened to do some OWASP stuff. The future of security belongs to the people who write the code, because you understand it. You know where that data's coming from. You know where it ends up. You know what happens to it on the way, and you know what you chose to build that software out of. You are the future of securing software, and I need every single one of you to start. And I have nothing to offer you, really, some stickers and a pin badge. But it's part of quality. It's part of saying my software is performant and scalable and usable and accessible and all of those things we want to do. I want you to add one more to that list and say to write good quality software is to write secure software, and that is not optional anymore. Now, I'm going to put my money where my mouth is, and this is not a sales pitch. You can stay on this free version forever. I do not care. I'm not here to hunt you down. That QR code there will get you and your team essential secure development training free of charge anywhere in the world. And you can do that right now. I have no qualms with you doing it. Yes, if you're bigger, you can totally buy things. It's a company, but we won't hassle you because we've put a line in the ground, and we've said enough is enough. The future of security isn't buying something. It's not a tool you buy from a vendor stand. It is not something that will solve your problems. It is not like buying a treadmill and hoping it makes you fit. The future of security is changing the way you think and making yourself and everyone in your team part of the security team and doing one little tiny thing every day to build that secure future as you build the technology that is some of the most exciting the world has ever seen. So that's a bit preachy for a keynote. I admit it. It's 9 o'clock in the morning, and you've done very, very well. But I would encourage you to get involved there. And if it's not that, find something else. Go download OWASP Juice Shop. Go look out into the world and find your way to join the team of 30 million software developers so that I can step back and you can show me how amazing the future of technology is going to be and how it's going to be secure from day one. Thank you so much. If not, you will find me loitering around. Yeah, that's what I do at conferences. I have stickers and pin badges. I like to talk about security. And I'm an introvert playing very hard at being an extrovert, so don't be shy. So lovely to meet you all. Thank you so much, and enjoy your conference.